Hey guys, in this video the lovely Miss B is going to be taking you through function graphs, the first parts of function graphs that you need for your A-level maths. Now there are lots of examples in this one. Work through at 3 different levels nice and slowly, and if you check the pinned comment down below you can jump between the levels working at your own pace. If you want a load more questions to check that you understand this skill, then there are loads waiting for you over my website.
We're going to have a look at the transformations of graphs. And our first transformation is that our function x, so f of x just represents a line you can see. So let's label it. This is a line, f of x. Or we call it y equals f of x. So this would be something like, the y squared plus 3x, take away 3, whatever that's going to be, whatever that quadratic is. We're just condensing it down and calling it f of x. Now we are doing something to f of x. We are adding 3 to the x coordinates. Now, this is a little bit counterintuitive, but when we say we're adding 3, what that actually means is we're going to take away 3 from the x coordinates. So, for example, we can see that this graph, it cuts through the x-axis at -2 and at +4. So when we add 3 to this, what happens is those coordinates, they're going to move backwards by 3. Now, again, it was a +3, you think, well, is it not going to move to the right towards the positive side of the axes? And what you're going to think is, by adding 3 to this, we're making this curve happen 3 units earlier. So if I draw the curve, it's just going to be a sketch, it's not going to be entirely accurate. I'll try and keep it as parallel as possible, but it should go through this point. So if we move the curve 3 units like this, again, you can find other points as well. For example, the peak here, that's going to move 3 units to the left. The intercept is going to move 3 units to the left. So you can see my sketch going a little bit off track there. So let's correct the sketch. So this should be a little bit better. So again, what's happening here is that by adding 3, we are making the curve appear 3 units earlier. And to do that, we've actually taken 3 away from every single x coordinate on the curve. So let's do just a little list of these transformations. So if you've got f of x and the x is having something added to it, let's say plus a, then what that means is it's going to be a horizontal translation. We should probably write down that's a translation. We're moving the curve. So if it's positive, you move to the left, and if it's negative, you move to the right. So again, it works the opposite way of what you would expect. And so now I've got my sketch, and just make sure with your sketch that it just goes through all the important points in the correct places. So the x-intercepts, the y-intercepts, and also the turning point. If all of those on your curve, then other points on the curve being a little bit off isn't going to be too big of a deal. The last thing I should do, I should actually label this line as well. So this was f of x plus 3. And let's put the y equals in as well and make it as accurate as possible. So moving on to our next example. Now again, we're given a line, and this line is the function of x, or rather we could say y is equal to the function of x. So it'll be a quadratic. Again, it's going to either be an x squared term, maybe an x term, maybe a whole number term, but we don't know what the exact equation is. So we just call it f of x. What we do know is that we now need to transform it, and we're going to take 1 away from the x axis. Now, what does that mean? So we can see the -1 is next to the x, so we know we're looking at an x transformation. What we want to do is, if you think about time happening here and time going in a direction to the right, then what we want to do is make this appear 1 coordinate later, 1 square later on the x-axis. And again, if you look at the little key we made, if you've got an x plus or minus something, then with your translation, if it's negative, we're going to the right. We're making it appear later. So I'll just identify a few important coordinates. So we can have a look at the coordinates when we cross over the x-axis, the x-intercepts. They are going to move 1 position over. We don't look at the y-intercept, that's going to go off the page. We could have a look at the actual top of the graph here. Now we can see we're about -1.5 there. So if that moves across by 1, that'll be -0.5. And the same to the other one, it looks like it's around about -9.5. So we add 1 to it, it could be -8.5. Then we've got the bottom of this, so again that's going to move across by 1. Now I've identified a few key coordinates, we can sketch the transformation. So again, it's by no means going to be completely accurate, but as long as you try and stay parallel to the original curve, you should get a pretty good approximation of where it should be. Trickiest part draws the bottom, so perhaps do that last. Make sure you go through the coordinates you've identified, and now we have a sketch of our new line, and we can label our new line. It is y equals f of x minus 1. And so by shifting it one place to the right, we are making this curve happen one square later. We've kind of delayed the appearance of the curve if you read your graph from left to right. Let's have a look at another example. So for this one, we want to sketch y equals f of x minus 3. So we already have y is equal to f of x, which is the black line. And by taking away 3 from x, what we want on the x-axis is to make this appear 3 units later. And again, in our key, we can see that if our kind of plus a is a negative, it's take away 3 in this case, then it's going to be 3 units to the right. So choose some kind of key points to make your sketch. The top of the curve is always a good one. Let's move that 3 places. The bottom's also a good place. Let's move that 3 places. And then also the intercept with the other side of the page as well. Let's move that 3 places. Once you've drawn out your new coordinates, we can start to draw a line through and try and keep it parallel to the black line. Again, it's a sketch, so we're not looking for a massive amount of accuracy here, but it's got to go through the key coordinates, which I've highlighted. The last bit's going to be a little bit more difficult because we don't actually have it on the page to copy from, so just try and continue it the best you can. And once it's sketched, we can label it. This is y equals f of x minus 3. If you take away 3 from the x, that means that the curve is going to appear 3 units later on the x-axis. So 3 units further towards the right, further towards the positive section of the graph. Now, where transforming functions gets really, really confusing is when you compare the x-axis and the y-axis to each other. Now, for this one, we've got f of x, and then we've got a minus 3 outside the brackets. So we're doing something outside the brackets. So what could that mean? Now, it isn't really clear just looking at the equation as it is, but we can rearrange this equation. And if we rearrange it, I can add 3 to both sides and get y plus 3 is equal to f of x. And now you might be able to see what's going to happen here. The plus 3 is actually happening to the y-axis. So if you've got your plus a, as I've written in the key, inside the brackets, then you're doing a transformation onto the x coordinates, because it's right next to the x. If it's outside the brackets, then through rearrangement, you can see that that is being done to the y-axis and y-coordinates. Now, again, this is going to happen the opposite way of what you think. So if we have y plus 3 equals f of x, then we're actually going to go 3 downwards. So we can take the bottom of the curve and count down 3, and this is going to be the bottom of our new curve. We can look at the x-intercepts and go down 3 from those. And of course, there won't be x-intercepts anymore after the transformation. What you might want to do is just go to the x-axis and see if you can find a point on the curve that's 3 further up. So like roughly here, these would be the new x-intercepts, for example. Then you can go to the very top and you can go 3 down from there. So you're just picking out points, coordinates on the curve that you can transform. And then once you've got enough points, as long as you stay parallel, there'll be really good guides to make sure that you've got a sketch of the curve. As you get to the bottom, it won't necessarily look as parallel. So we're going to have something like that. And then we can label our 2 lines. So our new line, using the original terminology, was f of x minus 3. And just look, we went down by 3. That's interesting. And our original was y equals f of x. Now, the reason why this gets confusing is because, firstly, you have to rearrange to see the kind of actual true number. So it says minus 3, but it's actually a plus 3. And so we are making the curve appear kind of 3 units sooner if we read from the bottom up to the top. So again, just like the x-axis, it's the opposite way around. But the confusing thing is, in our original question, before we rearranged it, it says minus 3, and we did go down by 3. So really, with a y-axis transformation, you don't need to do any rearranging or even think about, doing it the opposite direction, because it plainly tell you, well, it's a minus 3, so you're going down by 3. And that's really confusing to look at the x-axis, because the x-axis said minus 3, you'd be adding 3. So you can't really treat both in the same way. You have to rearrange one or the other to truly understand what's going on. So the key is going to be good to remember this. So again, this is going to be a translation. If it's positive, you're going up, and if it's negative, you're going down. So the common shortcut is to say, well, the y-axis transformations, you just do what it says. Well, it's minus 3, I've gone down by 3. And the x-axis transformations, you do the opposite of what it says. And then you have to remember the difference. So what I hope I've shown you here is that actually, if you rearrange it properly, you have to do the opposite of it either way. But the way we rearrange it to get y equals to actually draw a line, actually just part of the work for us. So remember, y-axis transformations, works the way you'd kind of expect. X-axis transformations, it works the opposite way around. So moving on to our next example, we have y equals f of x plus 3. And again, if we rearrange this, we took 3 away from both sides. We have y take away 3 is equal to f of x, which is a reminder that this is happening to the y coordinates. Now, if you look at your key, you can see that if the original is a plus 3, that means we are going upwards. So find key coordinates that we can transform. Try and find some whole number coordinates. So you can find the x-intercepts are often whole numbers, and they're going to go up by 3. You've got the bottom of the curve can go up by 3. You could have the y-intercept go up by 3, but it's quite close to the bottom of the curve actually. And then we can't really do the top of the graph here because we go up by 3, it's going to go off the graph. So maybe we could look 3 below the top and transform that up by 3. And actually they're whole numbers. That looks good. Once you've found some coordinates, try and sketch. Very often you can stick to the line parallel, especially with the x-axis, but with y-axis transformations, it's not going to stay parallel. But it's a good guide when you're up at the top. Down at the bottom, staying parallel is not a good guide. And so now we've got our new curve. And again, let's label it. So using color code, and it's really clear. This is f of x plus 3, and the original was y equals f of x. So again, going through the key points with translations, if you're adding or taking away to the x and it's inside the brackets, you're right next to the x, then that's a transformation on the x-axis. If your add or take away is outside the brackets, then that's a transformation on the y-axis, but you would have to rearrange it to get that number actually directly next to the y, like you would with the x. So it's a little bit less clear that it's a y-axis transformation. So that's something to remember. Then the other thing is, with the y-axis transformations, because it's always already rearranged in a way, if it's, plus 5, you go up 5. If it's minus 5, you go down 5. It works the way you'd expect. Whereas with the x-axis, because it hasn't been rearranged, it's going to work the opposite way. Because it should be working the opposite way for both axes anyway. So if you have a plus 5 inside the brackets, that's actually going to be a minus 5 on the x-axis of the graph. If you have a minus 5 inside the brackets, that's going to be a plus 5 to the x-coordinates on the graph. Yeah, there's a few tricky little features of this for you to remember. The next thing we're going to look at is reflection. So here we have f of x, and we're trying to find negative f of x. So we have to think, is this going to be a transformation on the x-axis or on the y-axis, so the x or the y coordinates? Now again, this is one where rearrangement is going to help us. So we can see that negative is not actually next to the x or next to the y. But what we could do is we multiplied through by negative 1, we flip the signs, and we get negative y is equal to f of x. And we can see that negative symbol is on the y, so that means that with our transformation, all the y coordinates are going to become negative. So we can write a generalized version of this. If your f of x has a negative on the outside, then that's going to be a reflection. And I'm going to show you, it's going to be a reflection in the x-axis. Now you might say, well, wait a minute, you just said that this is going to be with the y coordinates, it's negative y. We're going to make the y coordinates negative. So why is it an x-axis reflection? Well, let's have a look at what actually happens. So, for example, on the actual x-axis itself, these two coordinates are going to stay in the same place, because if we make the y coordinate negative, well, on the x-axis, the y coordinate is 0, so they're not going to change. So they'll stay where they are. Then the peak of the graph, now this is 1, 2, 3, 4, 5, that's 6 up. It's at 6 on the y-axis. If we make that negative, we're going to have negative 6 on the y-axis. And so the curve's going to be down there. You might also want to look at the bottom of the graph there. Here and here, these two places right at the bottom, y is negative 10. So y is going to be a positive 10 in the reflection. Just make sure in the same places on the x-axis. And now we can sketch the curve. This one's a little bit hard. There's no original curve to follow because it's a completely different orientation. But there's a good approximation of what the reflection would look like. So we've reflected all the y coordinates. Any positive coordinates have become negative, any negative coordinates have become positive. So what about this x-axis reflection I was talking about? Well, look at where the line of symmetry is going to be. The kind of line of symmetry through this, the line of reflection, goes through the x-axis. And again, this is a kind of point of this which makes it really confusing, because you've reflected the curve in the x-axis, but that actually means that the y coordinates are the ones that have changed and all the x coordinates have stayed the same. So again, just be aware of these points of confusion. And if you are confused, just go back to is the transformation on the x or the y. And in this case, if you go back to an original rearrangement, you can see, well, it's a negative y, so it's the y coordinates. So always know how to rearrange and kind of derive what you're doing. So moving on to our next example, you can either remember that if it's a negative f of x, it's going to be an x-axis reflection. You can draw your line of reflection and you can try and sketch it that way. That might not be the best way though, because the best way is, you think about how you rearrange this, multiply both sides by -1, you get negative y is equal to f of x. That's a reminder that what's happening here is that the y coordinates are having the sign flipped. And if positive coordinates become negative, and then negative become positive. So the best way to look at this really is to kind of look at any identifiable spots of the graph, like the very top of the graph here. I think, well, these are y is equal to 10. So in the reflection, that'd be y is equal to -10, but they'll be on the same place on the x-axis line. The curve is just below the line, so it'll be just above in the reflection. Perhaps look at the y-intercept, so that looks like it's at 6, so that'll be -6 in the reflection. And just trying to identify a point to help you draw the curve. Maybe we can have the other side that's equal height to the y-intercept, and we've probably got enough now to sketch it. It's just a sketch, don't worry, it's not 100% accurate, but we want to get as close as we can. And there it is. So we've done an x-axis reflection, which means that all the y coordinates have had the sign flipped. We've only changed the y coordinates. Change the y coordinates because the negative symbol should be on the y. If it's not on the y, you can rearrange it to be on the y. In our next example, with our f of x, the negative symbol is on the x. So that's going to work exactly the same way as the negative symbols on the y. But rather than change the signs on the y coordinates, we're going to change the signs on the x coordinates. So again, this is going to be a reflection. As I'll see in a moment, this will be a reflection in the y-axis. So identify some important coordinates. So for example, the x-intercepts are at 3 and 9. So in our reflection, they'll be at -3 and -9. The very bottom of the curve is at 6. So in our reflection, it will be at -6. Notice I'm not mentioning the y part of the coordinate, which is -9, because that's not going to change. It's going to stay at -9. But I could look at the very top here. Now, it's not quite at 2. Perhaps we could look at where it is at 2. So that'll be -2 in the reflection. See the very, very top's about a quarter further on. So we're looking at something like this. Perhaps we can look at where it goes off the page, roughly around about here. So that's at x is 10. So that'll be x at -10 on the other side. So now we could try and draw the curve best we can with the points we've got. If you're not confident with the number of coordinates you've got, try and find some more coordinates to help guide you. But it's only a sketch, it doesn't need to be 100% accurate. So we've got something that will roughly look like this. Now, I'm not doing this for every question, but do label these as well. So we've got y equals f of -x, pink line, and the black line was y is equal to f of x, which was given to us as part of the question. Now, I said this was the y-axis reflection, because if we put a mirror line, a line of reflection through the y-axis, you can see it's on the same on both sides, like a mirror. But again, even though it's the y-axis reflection, what actually changes is the signs on the x coordinates. So again, there's a lot of kind of opposite meanings here that can be very confusing. So the bottom line is, if you're not sure where to reflect, have a look at where the negative symbol is. And for this one, the negative symbol was on the x. So the x coordinates change. So moving on to our next question. Again, we can see the negative symbol is on the x. So this is going to be a transformation of the x coordinates. So identify some coordinates on your curve. So for example, we've got x is equal to -9 and -5. So if it was negative, we'd have -9, which is +9, and -5, which is a +5. We can have a look at the peak. That's at -7. So -7 would be +7. Perhaps we can also have a look at the bottom as well. So this is just after -3. That'll be just after +3. Let's look at where it goes off the page. So that's going to be at -10. So at the same height over at the other side at +10. Now we can start our sketch. We can label it and make sure we label the original as well, so we can tell the difference. And again, even though we changed all the x coordinates and changed the signs on them, if the positive become negative and the negative become positive, this is actually a reflection through the y-axis. So that's where our line of symmetry or our line of reflection would go. So let's look at our final example of reflections. And again, the negative symbol is on the x. So this is going to be reflecting the x coordinates. So find some coordinates. So these coordinates are 1, 0 and 4, 0. So the x coordinate will be reflected from 1, 0 to -1, 0. The y coordinate staying the same. And from 4, 0 to -4, 0. Again, with the y coordinate staying the same. That's why I'm ignoring the y coordinates. The peak is when x is equal to 3. So at the same height on y, That's going to be when x is equal to -3. In fact, it's at 2.5, it's a little bit further back. We can see the y-intercept. That's not going to change because that's when x is equal to 0. And anywhere where x equals to 0 is going to stay the same. We can look at the bottom, we've got -1 will become +1, and we've got +6 will become -6. Now we have our coordinates, we can start to draw a curve. And for this one is going to overlap. So now we have our two curves. We have our original curve, y is a function of x, and we have our new line, y is equal to the same function of x, but x is negative. Moving on to our next type of transformation. And again, rearranging is going to be useful to see what's actually going on here. So if we actually multiply both sides by 2, we're going to get 2y is equal to f of x. So we can see that this is going to be a transformation on the y coordinates. And it's 2y, it's going to be something to do with multiplication. Now, going back to this kind of working the opposite way of what you'd think with the translations, it's the same with enlargements as well that we're going to look at here. And so if we've got a 2y, we're actually going to do the opposite of 2y, which is going to be dividing by 2. So take a coordinate. So let's look at the turning point of the curve. Now, the y coordinate here is -9. So you divide that by 2 and you get 4.5. And so that's going to be the new bottom of our curve. The x-intercepts, they're going to stay as they are because that's when y is equal to 0. And you divide that by 2, it's going to stay the same. Perhaps you could look at the very top. So now this is where y is equal to 10. So half of that is y is equal to 5. Stay in the same place on the x-axis, but now we're at 5 on the y-axis. And then we could probably have a bit of a go at sketching it from those 3 coordinates, but you might want a few more as well, just as a guide. In fact, I've got 5 because the x-intercepts are the same as the old ones. So we can have a go at sketching this. So it's going to be something like this. And again, it's only a sketch, so there were a few bits where I don't like what I've drawn here, particularly the last bit. So maybe we'll have another go at that. But overall, it's a sketch, so it's not too bad. Now, looking at this, you might be thinking, well, what's going on with this? Why did I have to have, what's the actual kind of theory behind this? One way to think about it is, since in the rearrangement this is 2y, if you think about the part of this that was part of the original line, these are the 5 original coordinates that I drew my curve in between. Then I had to extend it at the top, and now we've got a kind of blank bit at the bottom as well. So what's happening here really is we're seeing twice as much of this curve. We've kind of almost zoomed out our viewpoint. We can see the bottom of the curve, we can see the old top of the curve, we can see even more of the curve now at the top, and we can see a blank bit down at the bottom. We're seeing twice as much stuff. So it's kind of, we're making it display at half the size so we can see twice as much of it. Now, a little key is going to be useful for this. So let's say we have a f of x. That's going to be an enlargement. It's going to be, we'll call it stretch really on curves. And if it's a whole number, then it's going to be a stretch outwards, making it bigger. So that'll be multiplied by a. If it's written as a fraction instead, like we have in this question, then we're actually going to be kind of stretching it inwards. Draw my arrows the other way around. And we're dividing our y coordinates by a. So moving on to our next example. So our number 2 is outside of f of x. So we rearranged it, that would be on the y, so it's going to be a y transformation. And as we can see in our key, if this is a whole number, we're going to be multiplying by it. So find some y coordinates. So for example, the bottom of the curve, y is -2. So we times it by 2, y is now going to be at -4. The x-intercepts will stay the same because that's when y is 0, so times it by 2 will have no difference. Now it's going to be hard to look at the top of the curve. Now this graph was up to 10, so we look at where it's up to 5. When y is equal to 5, this will be the coordinate where y is going to be equal to 10 at the top. So now we've got 5 coordinates, we can start to sketch this. So it's going to be something like this. And so what we've done is we've kind of stretched the curve to be kind of like twice the height. Now the bit that we can only see the bit really where the kind of bottom section below the x-axis has been stretched to twice the height. So you're not going to be able to see the full thing. But if you imagine that the kind of viewpoint was zoomed further out, then our original curve is now, instead of being between 10 and -2, it's now going to be between 20 and -4. We can only see the -4 bit here. So let's look at another example. This is a third f of x. That means we're dividing the y coordinates by 3. So the top's just over 0, so that's probably going to stay roughly where it is. And of course, the x-intercepts stay where they are. The y-intercept's at -2. So if we divide that by 3, then that's going to actually be 2/3. The position of the bottom of the curve, which is at -10, we divide that by 3, it's going to be -3 1/3, roughly here. So if we sketch what we've got so far, what we're going to see is we have something like this. So we can see the curve is actually getting quite wide here. So it's probably going to stay wide as we go towards the bottom. And so what we've done here is by dividing it by 3, we're just looking at the kind of bottom third of our graph. So the section highlighting in purple here, this is the original black line. And so we're basically looking at that black line in more detail. It's kind of zoomed closer in, or it's kind of zoomed further out actually. Then we can see there's new parts of the line that were previously out of our viewing area that we can now see coming in. Again, the effect it's had here is essentially kind of squashing the line downwards. So it's kind of squashing it in. And you take, a long thin thing and you squash it, you're going to make it shorter and wider, which is what's happened here. In the next example, you can see now the number is on the X. So now we're looking at doing stretches with the X coordinates. So practically enlarging the X coordinates. Now, when we have the number on the X, like we have in this question, again, remember these things. Once we rearrange the numbers next to the letter it's transforming, it's going to work in the opposite way that you expect. So when you have a 2 next to your X, what you're actually going to be doing is going to be dividing by 2. Now, if you rewrite this to be a more general function, so let's call it A instead, then we're going to be dividing by A. And this is going to be squashing the x-axis in itself. If we have a fraction on X instead, then that's going to be where you multiply and we stretch the x-axis outwards. So looking at this one, we've got 2x, we're dividing by 2. So find some x coordinates. So for example, we have our x-intercepts of 2 and 7. If you divide those by 2, we're going to get 1 and we're going to get 3.5. We can have a look at the bottom of this. This is going to be at 5. So divide that by 2. It's now going to be at 2.5. The very top is going to be at x is a half. So it'll be at a quarter. Divide by 2. Very close to it. And then the other place at the top of the graph is at 8.5. So divide that by 2, we're going to get 4.25. So now we can try and sketch this. And what you see is this is going to be a lot narrower. Again, we've kind of squashed it in itself. It's now half the width. And it's also moved a bit closer to the y-axis as well. So it's not in exactly the same position as before. With our final example, we can see that we have a number next to the x. So we're looking at an x transformation. It's a coefficient on the x. It's kind of multiplying the x. So it's going to be an enlargement. We're going to be stretching this or squashing it. And it's a third. So you imagine it should be doing the opposite of what it looks like. So this will be a multiply by 3. So have a look at the x coordinates we can identify. So one x-intercept is at 1, multiply it by 3, it'll be at 3. One of them is at -3, multiply that by 3, and we're going to get -9. The bottom is at 1, -1 rather, so we'll multiply that by 3, and we'll get -3. And we should look at the tops as well. So we've got right at the top, we're going through x is 2.5. So multiply by 3, and we get 7.5. At the other side, now the top of this is just before 5. Multiply that by 3, we get 15. So we are going to go off the graph here. Now, if we sketch what we've got so far, you can see that we've made this a lot wider. We've made it 3 times wider. So it's kind of stretched it outwards. I'm going to come around a curve at this point here, and then it's going to go off the page. So our new curve is going to look something like that. So the big things to remember are, if you're not sure what to do, rearrange the equation of the line. So whatever number's involved in it, it's on either the x or the y. So then you know which coordinate you're changing. Once you know which coordinate you're changing, in the rearranged form, where whatever you have is next to the x or y, it's going to be the opposite of what you'd expect. So if it's a minus, it'll be a plus. If it's a plus, it'll be a minus. If it's a multiply, it'll be a divide. If it's divide, it'll be a multiply. However, the versions with x, where the numbers on the x, that's usually how it's given to you as a question. So you don't have to do any rearranging there. But with the y coordinates, they're actually already they're not rearranged. And so it's going to be kind of the opposite way around. And obviously 2 opposites cancel out. So if you get a y coordinate that's got a +2 on it, then you have to add 2. It's not the opposite way you'd expect because it's not being rearranged to have that 2 be next to the y. So be very careful with the differences between the x and the y axis. Remember that pluses and minuses are translations, negative numbers are reflections, and then a coefficient is going to be a enlargement, so a number on the x that's multiplying it.